Okay, this is problem 2C. It says an electrophoresis experiment has a conducting gel of resistivity 8 ohm meters contained between two insulating plates. The plates are 20 centimeters long, 10 centimeters wide, with a space between them of 0.3 centimeters that is filled with the gel. A potential difference of 100 volts is applied as shown. The gel exerts a drag force that opposes the force from the electric field. The drag force is proportional to speed and has a magnitude of BV, where V is the speed and B is equal to 4 times 10 to the minus 11 Newton seconds per meter. The protein moves at a constant speed determined by the cancellation of these two forces. How far does the protein move after a run of 3 hours? And the protein has a charge of plus 4 electrons. Okay, so we have two plates like this. One has a positive charge on it and one has a negative charge on it. And the potential difference between these two plates is 100 volts. We've got a protein somewhere in between with a charge of plus 4 electrons, and that's going to move, it's going to be attracted toward this negative plate. And so the forces on it are the force due to the field and the force due to the drag from the gel. So if we draw this little force diagram, then the force of the electric field is the charge times the magnitude of the electric field, and the force due to the gel, the drag force, is B times the velocity of the protein in the gel. So B is given, and V is some velocity. And so our final answer is going to be that distance is the velocity times time, where the time was the 3 hours that we're running our electrophoresis experiment. So in order to find this, we need to find the velocity. In order to find the velocity, we need to balance that with the the drag force at that velocity with the force due to the electric field. And so to do that, we're going to need to find the electric field. So let's find the electric field between these two plates. So we know that the potential difference is 100 volts. So that's 100 volts across 20 centimeters. And the potential difference between 2 points is, say we have a constant electric field, which is true because we have two large plates. So the potential difference is just the electric field times the separation distance. So the separation is 20 centimeters, and the potential difference is 100 volts. So we know that we have 100 volts per 0.2 meters, which is 500 volts per meter. So this is our electric field that's constant between these two plates. So the force on this charge is the charge here, so 4 times, what's that number again? (1.6) times 10 to the minus 19 coulombs times the electric field, so 500 volts per meter. Okay, and a volt is a joule per coulomb. Okay, and a joule per meter is a force in newtons. So this will end up being some number in newtons. Okay, so now we know what the force in the towards this negative plate is, and that's equal to the drag force since it's moving at a constant velocity. So we know that B times V is Q times E. So our velocity is this, what we found here, divided by B. So 4 times 1.6 times 10 to the minus 19 coulombs times 500 volts per meter divided by B, which is 4 times 10 to the minus 11 Newton seconds per meter. And so this newtons was going to cancel this joules per meter that we had up here, and this is on the bottom. We'll get something in meters per second, which is our velocity. So taking this, this times our time in seconds is our total distance. And our time in seconds, we had 3 hours. So our final answer is distance is all this stuff. These 4's will cancel. So we have 1.6 times 500, 10 to the minus 19 over 10 to the minus 11 times 3 hours in seconds, which is 3 hours times 60 minutes per hour times 60 seconds per minute. And if you multiply all of this out, you'll get 8.65 centimeters. So this protein will move a total of 8.65 centimeters in the 3 hours that you're running through this gel.